Solid state Part 1. Solid state. As we have studied before, we can change the physical properties of an object or element by varying its temperature and pressure. This phenomenon is known as change of state. For example, when we heat water to turn it into water vapor or freeze it to turn it into ice. Intermolecular forces. Intermolecular forces exist between molecules of an element. They actually determine not only the state of the matter but also factors such as boiling point, melting point, enthalpy of the elements. They keep the atoms or molecules of matter close together in a bond. Thermal energy. Thermal energy is a form of kinetic energy. It is the energy that particles possess due to their motion. It is the internal energy of an object that is responsible for its temperature. Crystals have a structure made up of a regular arrangement of their atoms, or particles. When such an arrangement of atoms is represented in a three-dimensional structure, this is a crystal lattice. Number of particles in unit cells. A unit cell is a repeating structure whose specific arrangement makes up a cubic crystal system. However, a unit cell must not be confused with an atom or a particle. These atoms make up a unit cell. Tetrahedral voids. You will notice that a triangle-shaped void is seen in this type of alignment. The sphere which is in the depression will leave a void between itself and the sphere in the layer above. This void is the tetrahedral void. Octahedral voids. If you observe a three-dimensional structure of a crystal lattice, you will observe the gaps in between the spheres. These are the voids. As you see that tetrahedral voids are triangular in shape. When two such voids combine, forms octahedral void. Calculations of a unit cell. Now, as we know, a unit cell also has a cubic structure. It has 1, 2 or 4 atoms located at various lattice points. Now, with the help of geometry, some basic calculations and certain attributes of this cubic structure, we can find the density of a unit cell. This formula is the density of a unit cell. D equals mass of unit cell / volume of unit cell.